Now, sometimes it turns out that one set, maybe it's this one here, is actually contained in some other set. For example, if I call this set A and this set B, then everything in A is also in B. And here's how I would write that. I would say that A is a subset of B. Now, it almost looks like a C here, but it's its own font. Looks like that, almost like a C, like contained in. That's what it reminds me of. A is contained in B. But it could also be possible that you could write this, right? If A is completely contained in B, would this be true? A is contained in or possibly equal to B. That would mean something like this. Here's a set. Maybe I call that set A, and then I put it into set B, and when I draw B, it's exactly the same set. So A and B are the same. So that's this part right here. A is completely contained inside or could possibly be the same as B. Now, what do you think for these two sets here? Is this true? Could you write A is a subset of B? So is it true or not? So I'm going to write it. A is a subset of B. Well, if it's true, that means everything in A has to be found in B. 3 I can find in B, 4 is in B, 5 is in B. So this is a true statement. Now what about these two sets? S is 7, 8, 9, 10, and T is 6, 7, 8. What about S contained in T? Is S a subset of T? True or false? Well, if it's true, everything in S should be found in T. Well, here's a 9. I don't see that in T. And here's a 10. I don't see that in T either. So right now, this is false. So I could write a true statement, though, if I wrote this. S subset of T, and then I'd put the negation through it. So what does that say? It says S is not a subset of T. Another thing that we want to talk about is this set here. This is the universal set, and this is the set of all objects under consideration. So maybe I'm working with a problem, and the only numbers I'm really concerned with are these numbers here. 1, 2, 3, 4, 5, 6, and 7. Those are all the numbers that I need to concern myself with. Now I'm going to name this set, and I'm going to call it the universal set because it's everything I'm concerned with. And I'm going to call it this capital U for universal. Now, I don't want to confuse this with the symbol for union. It's different. Now, when I write it with this pen, it looks the same, but it really means the name of this universal set. This is the set of all the objects under consideration. So if I'm working with any set at all, then this has to be true. Any set that I'm working with in which I'm dealing with the universal set this has to be true. If I'm working with some set S, that has to be a subset of U, right? This is everything I'm considering, and I can only consider things that are part of the universe, right? I can't consider things that are not in the universe. So if I wrote this set here, or I write some set S, how about 1, 2, 7? Okay, sure enough, S is a subset of U. I would not even consider writing this set here. T equals, say, 8, 9, 10, because T is not a subset of U, and it has nothing to do with what I'm talking about. So I wouldn't even write that. Now, something that comes up often in counting is the set complement. So suppose S is some set. Now, here's what S complement is. S complement, and I'm going to write it like this. There's some other notations. You can write it like this, S, or you can write, some people write it with SC for complement. Some people I've seen like this. I'm going to write it like this. This is very common. So S complement, here's what this is. So S complement is this. It's the set of all elements that are in the universe, right? Everything has to be in the universe. So it's the set of everything that's in the universe that is outside of S, right? So I look at my set S, and then I just pick everything in the universe that's outside of it. Here's an example. Let's suppose the universe, all the numbers that we're considering, are these here. 1, 2, 3, 4, 5, 6, 7, 8. That's the only numbers that we're really concerned with. And then we have a set 1, 2, 3, 4. All right, now what we want to know is what is S prime? What is S complement? So S complement, this is the set of all numbers that are in the universe that are outside of S. So what's in S? 1, 2, 3, 4. What's outside is 5, 6, 7, 8.